The planet is heating up.
The oceans are becoming filled with plastic.
Change starts now. Change starts now.
We're on a countdown
To zero waste. 5, 4, 3, 2, 1.
This is the Zero Waste Countdown Podcast. Here's your host, Laura Nash.
Hello, everyone, and welcome to the Zero Waste Countdown podcast and radio show. We are speaking today with Cora Young. She is an atmospheric and analytical environmental chemist from York University. The Chemical and News Engineering magazine has named her to the Talented 12 list, which recognizes up-and-coming chemistry researchers and innovators who are tracking some of the world's most pressing issues. Cora, welcome to the show.
Thank you for having me.
I'm excited to talk to you about a lot of things today, actually. But first, I want to know all about the Talented 12. So what was that experience like? It seems like a pretty big honor.
It was a really big honor. I was nominated by two of my collaborators, which was an honor in itself. And I was totally overwhelmed to make the list. And yeah, I got to go to San Diego and meet with lots of prominent chemists. And it was a fabulous experience.
Oh, that's awesome. Were you nominated for like a particular study that you were doing or just like general your career?
It's some of my general work. Yeah.
So what I really wanted to talk to you about today is some forever chemicals that you have been researching, and you went up to the Arctic to do this. So tell us about that. So first of all, I love the Arctic. I'm a little obsessed with it, but I've never been. So I want to know kind of all about it and what you were doing up there.
Yeah, so the Arctic is a really interesting place because it's a pristine environment where we don't have a lot of local emissions of pollutants. So anything that we find up there, we know had to originate from somewhere else. So one of the things I find really interesting about the Arctic is understanding how chemicals get from where we emit them down here in lower latitudes, how they actually make it up to the Arctic. Because once they get there, it's a really cold environment, of course. They end up trapped there and really polluting a pristine environment.
Yeah, so we've talked a bit about like plastic being found in snow samples up there, which is really disappointing. So what kind of things were you finding up there?
Yeah, so we were looking for organic chemicals. We were looking for perfluoroalkyl substances, or PFAS, which have come up in the news quite a bit recently. We look for PFAS actually amongst several other types of chemicals, but we've been talking about PFAS a lot recently because our work was recently published on that topic. And so these are organic chemicals, and they're not really used in the Arctic. They're found in commercial products, and there are hardly any people up there to use it. So we know that they must be getting there from our sort of our environments where we are using them.
Yeah, absolutely. And I wonder kind of how they're getting up there. Well, do you have any theories on that?
Yeah, so we were able to learn a little bit from our studies. So one of the things that we can do in the Arctic as well is collect ice cores. And so ice cores are really neat because they actually preserve a long-term record of the pollutant deposition. So you can think about it kind of like tree rings where you can actually count back in time. And so by collecting an ice core, we can actually get the history of pollution that has arrived at the ice caps and glaciers. And that's really useful for helping us to figure out where these chemicals are coming from. And so some of these chemicals they're all being transported through the atmosphere, really. And so that's actually really useful if we want to do a better job of regulating these chemicals.
So an ice core is like going back in time a little bit, like what you said with the tree, right? You can kind of look and say, okay, this was like 100 years ago. Like, I'm not really quite sure. I think it's the layering, right? Like each season layers differently. Yeah, exactly.
So it kind of, if you look at an ice core, you can actually see the layers. Because it's frozen, these layers actually are preserved. So 1 year's snow will pile on top of the last year's snow and continuing on. And so from some ice caps, you can go back hundreds of thousands of years. For our study, we're really only interested in the past we're interested in a much shorter time span because of the types of questions we're asking. So our ice cores were more on the 40 to 50 year time span.
Yeah, so you can tell when these things were laid down, but how do you tell where? Are you looking at, like, I don't know, if a volcano erupts, you might see some of that or something?
Mm-hmm. Yeah, so we kind of use environmental forensic techniques to try and figure out where these chemicals came from. So we can use something called air mass back trajectories. So that's some modeling to figure out where air masses might have come from that might have delivered the chemicals. So that's using meteorology. We can look at the temporal trends. So we have 50 years worth of data. So we can figure out, say, the concentration started going up in 1990. So what was happening in 1990 that might have caused that to happen? We can look at the ratios of the chemicals we're interested to ratios of different things that we can understand. So it's kind of like using a bunch of different environmental forensic techniques to figure out where the chemicals came from.
That's very cool. Well, it would be cooler if you weren't finding like bad things, but it's a very neat process. But you were mentioning PFAS. Now, I think PFAS they were in the news a while ago because some food companies were, I guess, putting it on paper to like make the paper hold liquid.
Yes.
Yeah. And then we're finding that like it's probably not very good for people and it's a forever chemical. So like besides the obvious, like are forever chemicals really forever? Like do they go away in thousands of years? Like why are we calling them this?
Yeah, so forever is a relative thing. Yeah, I mean, no chemicals will be forever. I mean, eventually the Earth will be engulfed by the sun. So, forever is really meant on the time scale of our lives. So these chemicals will be around, when I'm gone, when my kids are gone, when my grandkids are gone, they're still going to be around. So it's sort of on the time scale of 1,000 years.
Okay, yeah.
Yeah.
And so why is PFAS problematic? Like, that's kind of all I know about it. Is there other things that you know about it?
So they're extremely persistent. So the fact that they are these kind of forever chemicals is really a big problem. And one of the challenges with things that are forever chemicals that don't break down in the environment is that we are committing ourselves to the pollution, right? So if we find out in 5 years that these chemicals are actually really toxic or they're really terrible or they kill frogs or something, then there's no going back. So when we emit these chemicals that are forever, that are very persistent, we're taking a risk.
Yeah. Were there other chemicals that you found as well?
We're in the process of looking at other chemicals, but in these types of ice cores, we have in the past found things like flame retardants and pesticides. So other chemicals that we are using in our daily lives also end up in the Arctic.
Mm-hmm. And how are these dangerous for the environment? Like, do they accumulate in animals? Are they ooh, really?
Yeah, so PFAS, as well as some of these other chemicals I've mentioned, they accumulate in animals. They biomagnify, and that can be a real concern. So again, even if we don't always understand what the health implications are for humans or animals right now, but because they are in the environment, they're accumulating in animals, they accumulate in us as well. And if we find out that there's a really terrible toxic effect, we're going to be in trouble.
Yeah. We had a scientist come on the show a long time ago that was studying microfibers in the ocean and microplastic in like shrimp and stuff. And then he said that the one thing they found kind of the most of in the bottom of the ocean was Teflon.
Yeah.
Did you find some of that too?
So Teflon is one of the sources of PFAS, actually. So PFAS is used in the production of Teflon. Yeah.
Oh, okay. I didn't know that. Interesting.
Yeah. So that's related. Yeah.
Oh, okay. So is this why they go on our pans to make our pans nonstick?
Yes.
And then they have a similar thing to go on paper and make paper not get wet? I don't know.
Exactly. Yeah. So it's actually the chemical properties of PFAS that makes it so useful. So basically PFAS, the properties repel water and also
Mhm.
repel fats. So, if you have Teflon coated khaki pants, then, if you spill olive oil on it, then it won't immediately soak in and stain your pants. You'll have some time to wipe it off.
Mhm.
Yeah.
Where is it accumulating then, if not in the fat? Because don't things normally accumulate in fats? Like, is it
Uh,
accumulating somewhere else
yeah,
in the
that's a
body?
great question. So PFAS, it does bioaccumulate and biomagnify, but not the same as many other chemicals that bioaccumulate and biomagnify. So as you said, yeah, that's right. Most of them accumulate in fat, but PFAS actually tends to accumulate in blood. So it's something that's
Oh.
known as proteinophilic. So it tends to associate with proteins as opposed to fat. So it's unique in that sense.
Oh,
Hmm.
that's very interesting. That's
Yeah,
weird.
yeah.
Hmm. I'm just trying to think of the implications of, like, if you're giving blood or something and then you're just giving people some
Right.
chemicals.
Well, I mean, it's in everybody's blood, unfortunately. So,
Really?
yep, yeah, everyone has PFAS in their blood. So,
And there's not really very many studies on, like, what it's doing so much? Like, it's kind of a
there
newer
are
thing?
there are several studies. I mean, one of the challenges with understanding the impacts of these chemicals is that we're all exposed to we're chronically exposed to low amounts, and understanding the implications of that is much more challenging than if there was an acute toxic effect, right? It's not like if you're exposed to PFAS, you're going to die tomorrow.
Yeah.
It's not what it's not like arsenic or something like that. It's more like a
Mhm.
chronic low dose exposure, and it's very difficult for us to actually understand that. If you think about how long it took for us to understand the negative implications of smoking, it's kind of like that, except the effects can be even more subtle.
Oh, yeah, and you'd have to take a
Hmm.
long time to do a study, and I think, usually
Exactly.
studies are fairly short. I know there's, like, the Harvard longevity study that's, like, 70 years or something, but I don't think many studies go that long, so, yeah.
Exactly.
Yeah, and did I read somewhere that these chemicals were replacing something else that was, like, bad for the environment?
Right. So, one of the things that came out of our most recent study was that the source of the PFAS in the Arctic was actually from CFC replacements. So,
Mm,
um, we obviously, CFCs we know destroy stratospheric ozone. It's very bad.
mhm.
And so we as a global community came together to ban CFCs to protect the ozone layer, which was great. But we replaced our CFCs with other chemicals, which then degraded, and their degradation products included some of these PFAS chemicals. And in our most recent study from the ice core, we learned that some of these CFC replacements were actually important sources of PFAS to the
Huh,
Arctic.
interesting.
Yeah.
So
Hmm.
if you're listening and maybe you're, like, young and you don't remember when this happened, I remember when it happened. But yeah, CFCs were a really bad thing. It was like, yeah, your hairspray is, like, killing the planet, basically. Like, every
Yeah.
time you spray it, it's basically like an aerosol, right? Is it,
Well, it was used as an aerosol propellant, right? So that's what it
propellant, yeah.
was. That was actually what was allowing your hairspray to come out. So CFCs were used in lots of things. Air conditioning is one of them. So CFCs and the
Oh.
replacements are no longer used in hairspray, most hairsprays anyway. But they are, I mean, they're really important for air conditioning. And of course, for many people, that's essential. And so we have to find alternative chemicals that we can use so that we can still have air conditioning.
Oh, wow, I didn't know that it was in air conditioning. That's very
Hmm.
interesting.
Yeah.
Yeah, because that's, like, one of the big kind of, like, cornerstones of development. I've read this, that so many
Yes.
people now have access to air conditioning, that it's, like, a good thing, and, in the '70s, like, hardly anyone did, and,
Yes.
uh, so now it's just, like, pumping out this stuff that's maybe not good.
Well, it's a challenge, yeah, because we want to make sure we can still have air conditioning, but we want to minimize the impacts of the chemicals that we use to air condition. Yeah.
Yeah. It's interesting talking about the trade-offs, because we talk about
Hmm.
this a lot with getting rid of plastic. Like, okay, are you
Hmm.
going to switch all of your plastic bags over to paper bags and then just, like, cut down all your forests? Like, sometimes we think we're doing a good thing by getting rid of something or whatever, and then you see that it's being replaced. And I've read this about, actually, my cousin's a chemist, and he told me that BPA was
Hmm.
replaced with BPS,
Yes.
but it's less studied and
Yes.
probably does something similar. So
Yes, that's a good example. And CFCs are kind of like that. So, we replace CFCs. We're actually on the third generation now of CFC replacements because we replace the CFCs, then we find out that the replacement has an issue, then we have to replace it again and again.
oh my
And
gosh.
so Yeah, I mean, we're trying to do better, but it's hard to foresee all of the impacts of chemicals when we introduce them into the market, right?
Yeah,
So,
absolutely. And
mhm,
like you said, it takes some time, right? Like you might not
yeah,
see anything really bad about it until time goes on.
exactly.
So I have a weird question for you then, because I have like a dry shampoo spray that I don't use very much, but it has like a spray function. So would that have like PFAS in it as a propellant?
Um, well, it's a CFC replacement. Not necessarily. So, one of the things that's happened actually as we've banned CFCs and tried to replace them is we've actually found non fluorinated and chlorinated alternatives. So, CFCs are chlorofluorocarbons, and it's the fluorine and chlorine in the chlorofluorocarbons that are actually causing a lot of the problems. And so, if we can make alternatives that don't have the chlorine and the fluorine, then those can actually be can be much greener. And so a lot of applications of CFCs have actually been replaced with non-halogenated alternatives.
So that's good. So it might not be that bad.
That's right. Yeah.
That's good to know then. Because I was going to ask you, like, what can we do to avoid these chemicals? Like, it's not on
Yeah.
my label of the dry shampoo, right? So how would I know?
Well, and Teflon is one of the things that can be
We can
related
avoid.
to PFAS, and you can sometimes avoid it, but it's Teflon
Yeah.
also is in products and not always labeled. But that being said, Teflon's not always a bad thing, and some of these products are very useful, and we want to. They certainly have a place in our lives. It's more about using them when they're most essential. So I'm not saying we should ban air conditioning. We certainly need air conditioning, but there are certainly opportunities to reduce superfluous use, let's say, of some of these chemicals.
Yeah. Or like when you put on the air conditioning and then like go get a sweater and like
Yeah,
flippers and stuff, maybe turn it down a bit, maybe.
exactly. Yes. Yes.
I have a heat pump, so I didn't want to go with the air conditioner. The heat
Hmm.
pump was supposed to be better, but it uses a refrigerant, so I wonder what the refrigerant is
It's going to be, yep,
it
it's
uses.
probably a CFC replacement. Yep.
Yeah, it's actually broken right now, so I haven't used it all summer, so I feel a little better about my environmental impact then in that case. Yeah, so I asked the last scientist who talked about
Mhm.
Teflon if he thought it was getting into our water supply from like kind of everybody just using forks in their Teflon pans and then washing it and like the Teflon
Mm.
goes down the drain. But I wonder if it's like being dumped or if it's just like getting in the air and then kind of raining down in the ocean. Like, do you guys have any idea of
Well,
why this?
Teflon's in a lot of things besides pans. I mean, actually, a lot of dental floss has a Teflon coating.
No, really? That's crazy.
Yes. So it's not always
Wow.
labeled. It's not always obvious. So I think there are probably. I mean, it's coming from all kinds of different products. You can get Teflon coated khaki pants. I wasn't joking when I gave that example earlier.
Oh, I
That's
thought you were.
that's a real product. Yeah.
Wow. Interesting.
Yeah.
It'd be good for people working in like kitchens, I guess.
I don't know.
Yeah. I don't know. I'm really worried about the floss though, if you're getting like chemicals in your blood because you're flossing. I use like a natural, oh gosh, it's like a silk thing, like
Yeah,
every time.
so the silk ones are probably Teflon free. Yeah. But certainly some brands certainly contain Teflon, and it's not always easy to find out which ones do.
Mhm.
That's a bit of a challenge, yeah.
Do you know of any other products that we kind of use every day that would?
Oh, that's a good question. I mean, it's mostly on textiles. So anything that
Mhm.
claims to be stain repellent will have likely has some sort of PFAS on it. And so, anytime you would wash that, you're likely releasing some of these chemicals into the environment.
I wonder if that's like furniture and carpet and stuff.
Yep, it includes those things. Yep, certainly.
Huh.
Um, and actually, one of the things you mentioned earlier was food paper packaging. So
Mhm.
a lot of fast food papers, they use PFAS on them because that PFAS prevents the grease from coming through and getting your fingers all dirty. So that's
Mhm.
another application that
Yeah.
may or may not be avoidable. Yeah.
I wonder if it's cheap to use, like, and that's why it's on everything. Because, like, if McDonald's is using it or something, just for an example, like with all their
Hmm.
hamburger wrappers, that's like billions of wrappers. So I don't think you could put like beeswax on it. Like, where would you ever get that much beeswax to do something natural? So it must be like cost effective, I would think, to
I
use.
would guess so. I'm not sure about that, but that seems
Yeah.
reasonable. Yeah.
Yeah. So let's talk about you a little bit. So,
Okay.
um, So what got you interested into studying these forever chemicals?
I became interested in them when I was an undergraduate student, and it was actually learning about their presence in the Arctic. I love polar bears and whales and seals and things, and so I was really upset that these chemicals were basically polluting these animals that live thousands of kilometers away from people using the chemicals. So I became really interested in learning how that happened.
Yeah, it doesn't seem fair that they have to deal with it when it's
Yeah,
not
well,
them.
of course, it's the people too who live up there who don't use the chemicals but then become exposed. Yeah.
That's what I was thinking about too, as the
Hmm.
communities as well, right? And they're
Yes,
probably
yes,
more dependent on like the sea life to live, I would
yes.
think.
It's definitely an example of environmental injustice. Definitely.
Oh yeah, that's a good point. Yeah.
Hmm.
Yeah. So how long did you spend up there?
When I went, I've only been once. I went in 2006, and I was there for a couple weeks. And I was there in May. I saw the eternal sun, and it was very cold.
Oh yeah.
It's
Yeah.
very confusing when you wake up in the middle of the night. I kept thinking it was morning, but no, it was 2 o'clock in the it was 2 o'clock in the morning. So yeah,
Oh yeah, that's crazy. It'd be
yeah.
very, very cool to see, I think. Did you go up on a ship or did you fly up?
We flew. So I actually went to an ice cap to collect something like an ice core, but it wasn't an ice core at that time. So you can fly on a commercial plane I flew to Resolute Bay, which is a community of about 200 people in the high Arctic. And then you have to take a private plane to take you to the ice cap. And the plane itself has skis. So you land, it's looks like kind of like a water plane, but you land on a makeshift runway on the ice cap.
Wow, that's very cool.
Hmm.
That's in Canada, right? Resolute Bay?
Yep. Yep.
Nice. In Nunavut, I think?
It's in Nunavut. Yes. Yeah.
Yeah, that's very cool. So this seems like you're doing like a really awesome career. Do you have like things coming up next, or is there something that you're working on currently that you can tell us about?
I'm working on all kinds of things. So we're still working on analyzing our ice cores. We try to collect a lot so that because every trip is very arduous, as you might have guessed from what I just said. And I do a lot of air quality work as well. So I'm looking at wintertime air quality, trying to understand that winter's a big part of our Canadian life, and air quality
Oh,
in the
yes.
winter isn't as well understood as summertime air quality. So that's something that I'm really interested in as well.
Oh, that's interesting. Yeah, because a
Mhm.
long time ago we used to get like a lot of smog warnings and stuff, and it
Yes.
seems like we don't anymore, which is kind of neat.
Yeah, we're doing a lot better. And I mean, across Canada and the US, we've done a really good job and Europe as well. We've done a really good job of imposing regulations that have improved our air quality. But a lot of what we understand about air quality comes from our measurements in the summertime. And wintertime is, that's half the year. And we can have
Yeah.
poor air quality in the winter, and it's just not as well understood.
Huh, that's very interesting. Cool. I look forward to reading about that. And so that'll be awesome. I love Canadian things just because like a lot of things always seem to be like American focused because it's just so
Yes,
much bigger and it's our
yes.
neighbor, so it's nice to see Canadians study in Canada. I just really like it. So if there are anyone out there who's listening who is
Mhm.
interested in science, do you have any advice for them if they're interested in like sustainability like studies, kind of like this one a little bit?
So, I mean, there are lots of resources out there to learn more, but I also advocate for, if there's a scientist whose work you think is really interesting, reach out to them. So, I love hearing from people in the public if they want to. I love hearing from students who want to work with me, and I know many scientists who are like that too. So, reach out because you never know what opportunity might be lurking.
Oh, that's awesome. And just the last question,
Hmm.
because it is a zero waste countdown show. Is there anything that you do in your own life to be sustainable, or maybe do you go to your way to avoid some of these forever chemicals?
Yeah, and so I'm very careful to avoid uh, synthetic chemicals whenever I can. That's one thing. I mean, that's sustainability, and also because I want to avoid my own exposure. So that's something I definitely look out for. I'm a advocate of public transit and walking. I hardly ever drive. I am very careful to not take planes. I guess that was in my former life. Now I can't really go anywhere by plane, even if I wanted to. And I am a vegetarian and have been for 20 years. So
Oh, wow.
I try my best.
Yeah, it's interesting. You can do so many different things, and I think people get weirded out, like if they're like not a vegan or something, and
Oh, no.
and they feel bad about it, but they're like, maybe they never fly, or they don't even own a car, or they don't buy anything in plastic, or maybe there is a vegan that buys lots of things in plastic. Like there's just so many things we can do in so many combinations, and we have to make
Exactly.
sure it fits our lives, right? Like not everyone. Like I don't live in Toronto. I can't walk, really
Exactly.
anywhere but to fields and stuff. So
Yeah. Yeah. And it's, every little thing helps. And actually, writing
yeah.
to your politicians is the number
Oh
one
yeah.
thing we can do. So we should all do that.
Yeah. If only they'd listen a little
Well,
more, but yeah. Awesome. Well, this has been great, Cora. It's been so nice talking to you. So thank you for doing these studies. They're very important, and it was definitely a pleasure.
same here. Thank you for having me.
Awesome. That was Cora Young. She's an atmospheric and analytical environmental chemist from York University in Toronto. I wanted to look into the issue of PFAS just a little bit more. So I looked up the American Environmental Protection Agency website. So it's epa.gov. And there's a little section on PFAS in there. So I'm just going to read this to you. Studies indicate that PFOA and PFOS can cause reproductive and developmental, liver and kidney, and immunological effects in laboratory animals. Both chemicals have caused tumors in animal studies, and the most consistent findings from human epidemiology studies are increased cholesterol levels among exposed populations, with more limited findings related to infant birth weights, effects on the immune system, cancer for PFOA, and thyroid hormone disruption for PFOS. Again, like Cora said, it's not killing us directly, but there are some concerns about what it's doing over long term in our bodies. If you're wondering why I would buy a can of dry shampoo when I always use shampoo bars instead, and I've used shampoo bars now for years. I was traveling with a little vial of cornstarch that I would put on my roots when I wasn't able to wash my hair very easily. And I wanted to see how the can of dry shampoo compared. And I definitely say the cornstarch works so much better. This dry shampoo spray can leave a residue. It smells very strong, and now I found out from Cora that there could be some very bad chemicals in the cans. So it was all around a bad decision to buy a can of dry shampoo. I still have the can, it's about half full, but I do like to try things before I dislike them, so I wanted to just give it a go and see how it compared to cornstarch, and I would say that it doesn't really. Cornstarch seemed to lighten my roots though, so if you have black hair, it might not work as well if that's kind of not the look you are going for. If you're participating in Plastic Free July this year, it's a little more difficult with COVID restrictions, but with a little creativity, some trial and error, of course, and some determination, it's certainly possible. I have a nice little over-the-shoulder cooler bag that I never leave the house without. I keep an ice pack in there. That way I have a nice cold water bottle throughout the day, and I'm not tempted to buy a plastic bottle beverage in the hot heat. And it was plus 35 degrees Celsius here the other day at my house in Canada. So we tend to get 9 months of cold and then 3 months of unbearable heat here, with a few weeks of grace period in between in the spring and fall. So the cooler bag really helps during the hot months, and I keep some snacks in there as well. A favorite summertime stop at the ice cream shop is a nice zero waste treat for kids. If you're on a road trip or cruising around town or looking for a reward to get the kids out of the house on a bike ride or a walk, a lot of places offer dairy-free and vegan options now as well. We never get the cups and spoons, always the cones, so they're zero waste, and we make a firm decision on what flavor we want instead of using those little plastic single-use testing spoons. If you'd like to support the show, there are several ways to do it. You can leave a review on Apple Podcasts. That would be super, super helpful. You can follow the show's Instagram, 0_waste_countdown, or you can find me on TikTok or subscribe to the YouTube channel, which doesn't have many videos. It's just the audio tracks of the podcast. Or if you want to reach out with a story idea, I'd love to hear from you. My email is laura@zerowastecountdown.com. And if you'd like to discuss anything on the show, you're welcome to email me as well. Podbean has a reward button that you can click right in the app to sign up for a monthly donation as well. Even a few dollars is super, super helpful. And probably the easiest way to donate to the Zero Waste Countdown initiative is to click the PayPal button on the bottom of the website, zerowastecountdown.com. Every action you do counts. So thank you so much for listening. I really appreciate it. And I hope that you have a wonderful summer.
Change starts now.
This is the Zero Waste Countdown Podcast.